All right. Hi, everybody. How's it going? So, today I have a good stream for you. Let's see if a few people pop in. Am I live? It looks like it here. Am I live on LinkedIn? Go on, LinkedIn. Yes. Okay. I think people can't see me. Can you see me? All right. People coming in. All right. Great. Yeah. Welcome, everybody. Today I have a good stream for you, especially if you are new into data engineering, if you want to learn it, if you want to get started. Hey, Vivek. Hey, Enoch. Oh, a lot of people there. Pedro, Akash. Hi. Hello, Yash. Prashant. Hey. Welcome, everybody. Anand. Hey. So, also welcome on YouTube, everybody. This morning I was on the Discord channel from Reddit Data Engineering. So Reddit r/data engineering. They have their own Discord channel with a lot of people. So might be interesting for you as well to check that one out. If you're into data engineering and if you have questions and stuff, they have a lot of people. I have mine with an open part and a lot for the academy students. But so the question was coming out of there. And the question, and I personally, I love that. I love the architecture part. I love building stuff. And so the question was from a student, not my student, it was from a learner. Let's say from a learner. That learner had a problem or wanted to build a project to get into data engineering, to maybe later show off to people. And so I want to show you what this person built, and let's analyze this and let's fix this. I already fixed it this morning in the Discord, but let's go over it. I want to show this to you. It's going to be interesting for you. You're going to learn something. And yeah. So the thing that the student created was, all the time say student, what I mean is by the learner. So again, that wasn't one of my students. From the left here, there's data coming in and going into Apache Kafka. And from there, the person said they want to build a Lambda architecture. That's why you find on the top a batch layer and then a speed layer on the bottom here, right? So Spark streaming for speed, for basically the streaming layer, and normal Spark with batch processes for the batch layer. This middle part makes absolutely sense. That's what you usually have. That's what's going to happen, right? Now, as you can see here on the left, there's data lake with Cassandra. That's already one thing. And then we also have Cassandra again here on the right as the serving layer. Now, I don't know if you have noticed this, but Cassandra is not a data lake, right? Usually data lake, when we speak of data lakes, we mean something where you have a file storage like AWS S3 or file storages on GCP and on Azure. And you put data in as files into a lake and then use that later. So there's already one very important part that I said this student needs to understand. That's Cassandra. Using Cassandra here is not good as a data lake. And also, one other thing was that the student was asking, okay, Cassandra used a lot of storage here. Can I make it so that I switch out Cassandra with something else? for instance, with Snowflake. Now, and I want to bring this over to you. It's very important to figure out, okay, what type of storage, what type of solution is this? Cassandra is a transactional database, OLTP data store. It's no SQL, but right, it's transaction based. It's based on, okay, here's something happening, here's coming in an event. That event gets stored in Cassandra, and then you draw it out again. So it's on the right here in the serving layer. That's already good. But so you have OLTP, then you would have OLAP, which is something where Snowflake falls in. It's more for the analytics part, on analytical processing instead of transaction processing. So these are not apples and oranges that this person was comparing with each other, right? Data Lake, OLTP, OLAP. So there was a lot of confusion here. Also, this arrow basically from Kafka to the data lake here. This is like this is not the. Let me see. Can I bring out my? Where's my drawing tool? Here it comes. So basically, this one. It's not thick enough. Sorry. So this one here, this path. This is not a like. You usually what you have in between, you would have a processing framework, right? Peter asks, will this stream be uploaded in YouTube? I have interest in watching. Yeah, Peter, that's going to be on YouTube. Your video has paused. Or is it just me? Is it paused for anybody? For somebody? Nobody else is complaining. So I'm just going to keep going. Right, so this, I don't think there's a direct approach to feed the data into Cassandra from Kafka. I don't know. I'm seeing a lot of no's here. Great. All right, it's working. So what I did is, I was thinking, how could we improve this? How could we make this clearer? One thing that learner also had, Cassandra was using a lot of storage or a lot of resources locally, and this person only had an 8 GB RAM notebook or something. So I advised to switch out Cassandra for something else in the same line, like MongoDB, or you could even use a Postgres database. So what I came up with is this. So I try to make this a bit clearer for this person. So how does this usually work? On the left, you have your client. And we didn't see that here. That was most likely the incoming data. And the client is going to send the data into Kafka most of the time. And from there, it's going to go into your streaming part. And if you want to run a Lambda architecture, most likely you will drop this as well into a data lake, right? You say, for instance, I'm doing the micro batches for Spark streaming. I'm doing at 1 minute. And then what happens is there's going to be coming a lot of messages in here. They all go into Spark streaming. And then as one big chunk, they're going to be then going to go into into the data lake. Hey, Woder. Yeah. Postgres is OLTP. I was thinking. I'm sorry. I need to say this. I think I pointed here. I was pointing more towards the serving layer here, to basically switch out Cassandra, leave out Cassandra, and do something else OLTP. So instead of Cassandra, that this person should use MongoDB. I'm sorry about the confusion. So this way, so we still have here in the middle, we still have our batch and stream processing, but we need to feed the data lake, and most likely we're going to feed that with one file every minute or so, depending for testing of its I would do this. Depends a bit on the speed that the data is coming in and so on. And or you could just drop the data into the data lake. Right? You don't necessarily need that. If you get the data from an external source, you could also, especially for a learner, you could just drop it in here. So, but the goal is you need to feed that through to the right. No, the other way around. For you, it's the other way around, to the right. Right? You need to feed it towards, and that's where the right is, towards the analyst, towards the end user. Right? And so that's where you use your streaming data, or your stream processing, get the data from Kafka, stream that through, maybe in 5-second micro batches, in 2 seconds micro batches. Depends on the amount of data that you send through and the time you want to have the data here in your OLTP database. So you would send it through, send it in here, and then have the data in your transactional database. I actually, while I was preparing for the stream, I was actually also thinking about, we could also do this here. And let me maybe, let me change this line. Of course, you could also, from your streaming, directly send the data into the OLAP system. Of course. But so that was the idea. So the person had here Cassandra as a serving in the serving layer, and that would be here Cassandra or MongoDB or Postgres that you could use. And then what is typically what you create? You set an API before that, and then have the website, your React website before that. So when an end user makes a call to the website then calls the API, and then the API then asks the data store, the database, to get the data and deliver that to the website, and the website's going to visualize everything, right? So that's where the streaming part is super important, because it's going to go through here, and it's going to go towards the end user. If you say, okay, I don't need live updates in my OLAP data store, right? This does not need to be every 5 seconds. Every minute or so is absolutely okay, or longer. You could then go the other way around, that you say, okay, I'm taking here my streaming, I'm going here up, put the data into the data lake, and then Spark is actually going to, with a like a 1 minute batch, with a 1 minute job that you schedule every minute. It's going to take the data and it's going to write the data here into the OLAP data store, or as I before, or write. Now let's make this that we also dot this line, or basically change that line as well, the other one. Let me do this. Right. So this is what you could do. And then the data gets forwarded into the Snowflake, and from there your data analyst sitting in front of Power BI or another tool is going to take the data, and it's going to look up the data in Snowflake and analyze it. And that's how you build the Lambda architecture. You could go without Snowflake here. They say, forget about the analysts. Let's set up these tools, set up a client. This could also be an API, Kafka, Spark streaming. Then move into a transactional database, and from there you have your API and your website and the user. Or the other way around, if you don't need this here, this lower part, because this lower part already exists, and you're just running analytics, you're just running business analytics, you could either go that route that you directly stream into OLAP, into the Snowflake, or that you go through the data lake route, that you first drop everything in the data lake, and then you run your batch analysis and stuff and feed it into the Snowflake. All right. So I think that makes this a bit clearer. So it's very important to understand the types of data stores that you are going to use. Cassandra is not a data lake. A data lake is always something, and that's my definition. Whenever I see a data lake, it's always something with files. I don't know about you, if you have seen something different and people call this different, but this is always something with files, and I would not use any store to call this data lake, especially in interviews. But by the way, why would you do that? So because you could say, okay, let me just quickly take these here. You could say, okay, I'm here, I use Spark, and instead of writing, I'm reading the data either like, let me see here, Snowflake. Let's say here we have our Cassandra. We could also have Snowflake here, and then let's have I don't know. Let's keep Snowflake here again, right? And then the results we're going to send over here, send into Snowflake. Again, that's not the intended use case. So first of all, again, these are not on the left side here. That it's not data lake, right? These are tools. You could also say here SQL database. And access the data here. Come on. But the big problem when you do this is Spark is going to run in parallel, right? You have multiple instances here, and depending on how large your cluster is, it's going to fan out and it's going to send over requests to each of these stores. So let's say you have 50 workers and it's a big job. It's going to spawn 50 query processes to your SQL database, and you're going to wreck that database because it's going to be overpowered by everything. So that is not the way to do it here. Now, don't do it like this. It's always bad because these these data stores are not made for these workloads. Snowflake maybe. Could maybe use Snowflake because it depends on it's always the same. Yes, a Snowflake is you can scale horizontally, so maybe Snowflake. But I would try to look and try to use the data lake for that. First feed your data into a data lake, and then you partition it in the data lake, and then you can easily query it with Spark and send it through. Right? Does that make sense, guys? Any questions around that? So that's basically what yeah. Let me know the questions in chat because it takes a second until everything comes here. Another thing was that this person wrote for Snowflake. He or she didn't find information about throughput and I think latency, or how long it takes until the data gets there for live dashboards, right? And that for live dashboards, that's because it doesn't make sense. That's not the intended purpose for Snowflake. You most likely are going to find that information, like how much throughput can you send through with that configuration, how much latency from trying to put data in it until it's there. Like you need to stage the file or stage the data. How long from staging the data until it's there? It's not the intended use case for this, right? So so it's very important to understand which tool to use when. Let's do this. Mustafa says, let's do this for Azure. Well, we we can basically do you can do a copy paste here. Here. Azure. So what would you do in Azure? Most likely you would have here, instead of Kafka, you would have Event Hub. Is it called Event Hub? I think it's called Event Hub. Spark, I think that is, well, how's it called? I think that's blob storage here. I think you can run Spark is, I think that falls under the how's it called? Synapse? Is that Synapse Analytics? I think so. I'm not 100% sure. Yeah, of course you could run data. Yeah, let's run Databricks here. I think, yeah, they have a, let's say Databricks Synapse. Mustafa, very good. Databricks / Synapse. Cassandra, here you most likely would use here something. You could use something like Cosmos DB here. Cosmos DB. That's API gateway. Website, you use Power BI, and here you use Synapse doesn't support the streaming part. Then you would most likely use here can you use Data Factory? Has Data Factory streaming? Transform data using streaming, Azure Stream Analytics. Maybe. Yeah. Azure Streaming Analytics. I'm not the super Azure guy, so that's true. Event Hub can stream directly into blob storage, so it's getting easier. And then here, I think that's also where you would have Synapse, right? As basically the data warehousing part. And then that's already it. See this? This works the same on Azure. It's no big deal. Yeah. And that's so the important part. So what did I just do with Azure? I was thinking of, okay, what are the tools that I know that are OLTP or OLAP and that are data lakes? Data lakes most likely is blob storage. I know Cosmos DB is OLTP, and I know that Synapse has two components. Has a component for basically working with tables and sending data through, and has the part of processing data with Spark. So that's why I went there. Like, yeah. Snowflake can be dropped and use Databricks SQL data warehouse. Snowflake SQL data warehouse. Yeah. That's you can, in Snowflake you could use both. Basically, you could use just Snowflake, or you set up another data warehouse on top of it. A SQL data warehouse works with both. I actually did that in one of my courses where I showed that you can query from Power BI with both options. I think the Snowflake SQL, that is actually the cluster then is meant for like you have Whew, now I need to try to remember. Oops. How is that? Because in Snowflake you have, let's say you have Snowflake, and then you have your SQL, Snow SQL? No, Snowflake. I would need to log in. Let me see. Let me quickly log into Snowflake. Come on, come on, come on. So you can go here. I think, do I still I think I don't have that anymore because I'm no longer with enterprise version. Can have a normal warehouse, but I think I can, with that I can no longer create the SQL part. I don't remember. Admin warehouse. No, that's just the normal. That's that again. No, I think I messed up. Doesn't matter. What do you mean by never read out of OLTP if you can avoid? Yeah, because because of the danger that you wreck your system, especially if you, like, the OLTP data stores are usually made for something where you have small requests, right? A user requests some data on the UI and just 1,000 times, but they're doing single reads of small data sets, small data points, amounts of data. And with and let's say you want to query a lot of data out of it, then the database has to really work, has to, like, you need to extract the data out of your store. You need to physically move the data or query the data from the store, send it over the internet or your network. First your network, then maybe over the internet, and then analyze the data. Well, forget about the internet. I think that was a stupid explanation. Let's keep with the local network. It needs to send the data over the network, and if you have a lot of systems that query data out of the database, that's a huge problem. So it's dangerous. It's dangerous because these systems are not meant for these large batch operations where you draw data out. Databricks have good products, so we don't need to learn many cloud services. You can't do everything with Databricks, and Databricks is like, let's go back to our image here. Let's stay here on AWS part, or here generally in this part. Like, okay, let's say we want to replace stuff here, and we would just add Databricks, right? So the batch processing, let's make this Databricks. Stream processing, yes, let's make this Databricks. The warehousing part, yep, let's do that. Data lake, maybe it's best to have an underlying data lake like AWS in there. Yes, you can store data directly within Databricks, but most likely you want to have something like that. A message queue, I don't think you can replace this with Databricks. Because it's the source of the data for Databricks. So that's not APIs. No, An OLTP system, I don't think as well. It's getting like, it's not like that you can say, okay, I'm just going to learn Databricks and that's it. That's not going to work. Jennifer has a really, really good point here. It's good to practice to separate your analytics platform for your transactional database. You don't want any time to negatively impact your production DB and cause downtime. I forgot to mention this. Of course, this is a, Jennifer, very, very good point. A very good point. If you want to, all the time, you want to split this up, your analytics workload from your transaction, from your live workload with the customers, basically. That's what I have here, right? You have the end users here on the bottom, and you have your analysts here on the top. Now, let's say someone here messes up and creates a really, 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 really big processing job. And that thing is going to fire off. And if that goes towards your live database, it's going to stall everything and nothing works anymore as long as this job's running, because this job is going to spawn Spark tasks, and these tasks are going to fire off and going to like time out your database. And then what? So that is something very good, Jennifer. That's a really, really good point. Always try to have that separation. Yeah. What ops tools do you need to learn for data engineering role? Operations side. So when I look at ops for data engineers, so what's the thing that happens most? Most likely you need to keep track of events, right? You need to figure out if something goes wrong and something throws an error, and you need to stay on top of that and get notified about that. You need to look into log files. You need to maybe or sift through logs if something goes wrong. So notifications, logs, then some performance insights, most likely with some charts and so on. The tools that are there are very, very wide. You could go, for instance, with log monitoring. You could look into Elasticsearch. Basically, that every log, every system sends the events into Elasticsearch, and then you can do a search, and you can also create charts there and dashboards, or stuff like a time series database and a Grafana dashboard, right? Where you need to stay on top of CPU, available CPUs, or of load, of processing times, of like stuff like the technical variables. Then most likely you would go and you would look into these tools like a time series database and a dashboard like Grafana. So these are, I think for ops, these are the two most important things. Something like Elasticsearch that helps you to collect logs at one place, to search through logs that you don't have to. And I did that before. It's like it's completely normal that you have an error. At first, you don't get notified that you have an error because the system isn't built for specifically that use case. Then you then you figure out that you have a problem. Okay, let's find the log files. Then you go and you either download the log files. Oh no, the log file is too large. We can't download it as easy. Let's open it up on the Linux console, and then you go to the Linux console and you try to find the problem that you have. It's that kind of stuff is super annoying. That's basically one part, and the other part is, okay, let's look at my technical statistics, my technical data, And let's look at our dashboard that has all the important information about data processing and so on it. I think with that, yeah, you're good. Yeah, I think Datadog is one of the things you can use there. Prometheus is also something you could use for these kind of use cases, I think. So, yeah. All right. Yeah. So that was for me. That was important to show you. How can you design a Lambda architecture, and what errors can you make? And that is very important to actually figure out. Figure that out, that part. Which tools go where and why do they go where? That's also something I teach in my academy, and that I have in my projects in the academy and so on. So that's because that is literally one of the most important things to understand in the beginning. It's not super hard, and then you need to try it out. You need to exercise, do projects, and hopefully that person that I sent this over is going to have fun with this, and it's going to help. Let's see if this person actually wrote back. No, I don't think so. No. Okay. Yeah. Anything else? Any more questions? Because, as I said, these were the things, that was what I wanted to show you today. I hope you had fun with this. I hope you learned something. Yeah. Let me know if you have a question. We're going to stay on for a few more minutes answering stuff. Then I'm going to go offline again. Multi-cloud strategy. Multi-cloud is always it's so let me quickly answer Augustine. Augustine, you can go to my YouTube channel. Let me bring it up here. Here's my YouTube channel, and you can just go here on, I think, in live, and then you see the newest here, right? That's where you find this, Andreas Kretz. So if you're not subscribed to that, subscribe to that. That's where all the recordings are. That's where you're always going to find the newest stuff. Yeah. So multi-cloud strategy is not that easy. I don't know. Does it already count Azure and Databricks? That's very specific. DevOps. I mean, it's yes. Why not? I mean, something that I'm currently working on bringing into the academy is a lot with CI/CD, because CI/CD is important, so that when you deploy something, or when you code something, automatically gets you upload it to your GitHub repo, for instance. You run a GitHub action. That thing is going to check if everything is like, if the unit tests work, and then build a Docker container, and that Docker container then gets automatically deployed on AWS or something, right? So that is, yeah, that is important. That makes sense. Why is Databricks not managed in AWS like Azure Databricks? I'm guessing it's the integration. They haven't integrated it in that way. if you spin up your Databricks cloud, then you're asked where do you want to deploy this, and you can select AWS there. But then you just see the resources there, the EC2 instances where everything is running on. It's pretty neat. So it's just the integration part. They haven't integrated it that far. Maybe Microsoft paid enough for that. Do you think it would make sense to have a data lake for structured data only and small data sets? It always depends on the use case for that. I mean, it doesn't really hurt to send, if most data is always structured that is in the data lake, it's most likely a CSV format, or it's going to be in a format of JSON files with JSON strings in them, or it's going to be, I don't know, Parquet files or something. So it's although we sometimes call it unstructured, most of the time this stuff is structured. So don't worry about that. If the data is very small, I don't know, it might make sense to, it depends on what you're doing with that. It doesn't hurt to drop it into a data lake, but if it's very small, why not put it into a database or in a data store? Microsoft failed to make HD Insight and Data Factory good for running Spark jobs. For that, Azure brings up. Yeah, that's true. We can figure it out ourselves. We struggle. Let's get it from somewhere else. Yeah, I mean, that's the Microsoft way, and why not? Why not? If it works, it works. I mean, good for them. Why companies mention Java for roles like machine learning? No idea. I don't think anybody who's doing machine learning is interested in Java. I don't know. Like, really? Doesn't, like, most likely they're using either R or Python. With the current libraries, I think Python is the one to go. But yeah. All right. So yeah, that was it for today. Thanks everybody for being here. What I'm going to do now, it's 4:45. I'm going to, what do I have on my list here after our stream? I'm going to post something on social media about Medium. We have on our Medium publication, Plumbers of Data Science, we have 3 new stories that people send over. So I'm going to send out one later. And yeah, then for me, it's almost it. Yeah. Thanks for being here again. Hope you learned something. I hope you had fun. Yeah, see you next time.